Today we're going to be introducing Rock. It's a portable vibration monitor with its accompanying SES software. The target of Rock is to make structural vibration accessible and, most importantly, easy to use. Quick notes about the modal shop. PCB specializes in the design and manufacturing of sensors, our sister company, accelerometers and such. Modal Shop focuses on delivering systems and services to support the application of PCB sensor users. PCB and the Modal Shop are part of MTS Sensors. We offer a wide sensing support network around the globe. And one of our main focuses at the Modal Shop is rental of sound and vibration solutions, as well as metrology, shakers, other related products. Our partner company, SYSCOM, that manufactures Rock that we're discussing here, are Swiss-based. They're in the west central part of Switzerland, and they've been in the seismic monitoring industry since the 1980s. SYSCOM's a subsidiary of Bartec, a world-leading provider of industrial safety technology. Chad presents with me often on the series. He's been with the Modal Shop about 7 years now, an application engineer, supporting both rental and structural test projects. That's Bruce. That's me. I lead the systems teams for both rental and recalibration services. And I dislike overly complicated solutions, cabling issues, construction delays, and presentations that are just read. So to kind of avoid the spoiler, this is it. This is Rock. We're going to go into all the features later in the presentation. Just keep in mind that it's a fully contained solution. An IP-rated enclosure with a built-in triaxial sensors, analyzer, battery, modem, and a data plan. Everything built in. With a normal test configuration, Rock can be set up, turned on by a single button press, and it's ready to take data. With reports and text message alerts in real time that are easy to set up, and it works autonomously for months and months at a time, operating on the internal battery only. Rock is rental only worldwide. And though it's offered in most major markets, we do want to note today that the Modal Shop is renting in the United States only. SYSCOM does make permanent monitoring solutions. Rock is a perfect project-based system, meaning it's available only for rental with just a monthly flat fee per device. There's no depreciation, no amortization, no surprises. And it lets you really avoid a lot of the cost of ownership issues that you'd have with monitoring systems. Overview for today, we're going to kind of look over why we're monitoring to begin with, some of the specs and features and benefits of this product, a quick overview of the software that you get and what its role is, and some quick fly through some typical case studies. Why monitor? This may seem trivial, but it's really worth noting. A lot of times in North America, we've taken for granted open spaces and relatively new construction. As a result, a lot of our vibration monitoring for construction-related issues has been less measured or regulated compared with other countries. A combination of growth and revitalization of urban cores mixed with aging structures means it's an area that's become a lot more important to measure. And there are a few ways to look at the whys. But in general, risk of can be any combination of factors, including avoiding property damage, causing delays in work or lawsuits. You can inform any stakeholders of any monitored activity, like a construction team or the public, for example. And some actions could be used to determine what needs to be next, if something needs to be stopped or the next steps taken. You can comply with any state or local regulatory guidelines or laws or standards. And a fourth big reason to why monitor is defend any claims that may occur that you may have caused damage on a property or a structure or something. What to measure or where used, I guess. This can kind of be a generally any vibration sensitive site, from places where people are to any construction that may be susceptible to damage, or even machinery that may be especially prone to not working correctly if outside vibration is present. From historic structures or a big one, any sensitive equipment like a LASIK or MRI machine, schools or churches, or even just residential. The vibration sources that we're monitoring here, usually the usual suspects: roads, trains, to motors or pumps or elevators, even human movement. This can form a basis of background measurement or determine if additional controls need to be in place, something like vibration isolation pads for equipment installation or something like that. But often, construction sources are often short-term monitoring reason. The sources of construction vibration are fairly well known: pile driving, blasting, excavating, compacting. So what rock does is it can be deployed anywhere inside or outside, anywhere a bit out of the beaten path by people or vehicles, but still in range of a cell signal, is generally an acceptable location for rock installation during the monitoring period. We've talked a bit about how there aren't a lot of national standards in the US for this type of testing. A lot of it is based on state or regional codes or guidelines, but a few are out there and are included in rock, like the Bureau of Mines RI 507 for structural response and damage produced by ground vibration from surface mine blasting, and the Office of Surface Mining Reclamation and Enforcement Standard in the Explosive Engineers Performance Specs for ground vibration. But, don't worry too much. The rock is customizable to any standards being tested. And it's worth noting that even in the States, sometimes testing is performed to international standards, which are also included in rock. Some of the specs overview for the transducers being used. Geophone sensors are used to monitor, transverse, vertical, and longitudinal velocity. It's a best-in-class sensor used with wide frequency and amplitude range. So with rock, there's really no need to use different geophones when testing to different standards. We use a configuration in the SGS software instead. And remember that positioning compared with Earth gravity is important for geophones. So rocks are either configured for ground installation or wall installation. And also, it's really important to note that individualized traceable calibration provided with each rock. Monitoring outside of our, we're having road construction outside of the new model shop right now. But the analyzer is the same device. It's very small and maybe still tough to tell from this picture, but we'll clear that up in a bit. In a lot of older systems, you'd need to cable up the geophones to a seismograph or some vibration monitor. There's no need with rock. Processing is done internally in the same box. This eliminates a lot of hassle dealing with cabling and associated troubleshooting. If you're setting it up, it includes the SYSCOM cloud software that both manages and sets up things like sample rates, frequency ranges, units, triggering, and background measurement settings. And there's also a state of health notification. It's an optional setting that we recommend. It sends an email and text notification in case of test pulse fail, low battery with less than 10% autonomy remaining, or if connectivity is lost. Rock can be set up to measure both events and background in the same setup. Background measurements give a sense of trends over time and can provide assurance that everything's working well. Various modes and options are available. Peak is almost a given. You can also measure vector sum and/or the dominant frequency, or it can even be set up to measure specific background measurement standards. Background reports are sent during the synchronization period, and these reports can also be emailed, but they're also stored on the server, so there's no worry of missing things. Event recording Unlike background reports, events are sent as soon as they occur. So for events, you'd set up a trigger level in the SCS software on any of the three axes. During an event, signals are going to be recorded and then saved when a trigger level is exceeded. An event length includes data from both before and after the duration as shown in the graph. And after the recording, the event is immediately pushed to the cloud for automatic post-processing. And this could include, notifying stakeholders by text or something, or email alerts as well. You get a full multi-page report per event, actually. It's based on your setup. You can change it at any time. You can get notifications via email or text. If you're worried you missed something, everything is databased on the SCS server. So this system cloud software we've been talking about a lot for the last few slides, behind the scenes, that SYSCOM cloud software or SCS provides integrated system working to post-process, report, and store all the data from any rock units used in various locations. Unlimited use of the SCS with data communication, storage, email, and reports are included every time you rent the rock. Kind of gives you a handle of the actual size of the unit. But remember, the modem and the data plan are built in, and this thing lasts forever. 6 months is the stated spec, but SYSCOM has a published paper where it substantially exceeds 6 months, and it's set up with real-life measurements, 1,000 hertz sampling, frequency up to 315 hertz, triggering at 1 millimeter per second on all axes, pre and post event recording, background measurements, and SCS synchronization to the software every hour. The main factors affecting battery life are going to be the duration and the number of the events, and the synchronization period, which sends background measurements and updates the parameters to the rock if needed. And a version of the rock exists with a small solar panel when used outdoors that can extend the life even further. And the enclosure is IP65 rated. It's ideal use for outdoor, even with condensation and rain. Don't put the rock, submerge them in water, or put them anywhere that might flood, of course. But other than that, it's pretty robust. To operate it, you just press the button for a second. Very simple. It'll be off and running with the setup that you've used to set it up on SCS software. To turn it off, the same button, you do a long press for 3 seconds. And on the device itself, there's a series of 3 LED lights that show system status, if the box is recording an event, and the 4G communication status. There's a bubble level included at the top of rock to ensure that it's mounted properly. And there's a few accessories available. A mounting plate to level it, some pointed screws for ground vibration, a wall mounting plate if affixing to in a horizontal configuration, an anti-theft cover, an external category or M1 antenna that isn't used very frequently. Usually the antenna, the small one built in, is fine. In carrying cases if you're going to deploy a number of rock around a construction site or something. And really, the setup, the quick start, it's 3 steps. You first charge the rock hardware battery. It's a deep charge. It could take over a day. And 2, you log into the SCS account provided with the rental, which you can actually have access to before you physically receive rocks. You create a project and you take in and assign rocks in your account to the project. You turn them on and select the duration, the parameters, including the triggers and alarms. And finally, you set the reporting and notifications. It all really just takes a few minutes. And finally, for the final step, you install rock where there's 4G coverage, push the on-off button for a second, and you verify the green LEDs on the hardware. And While you're there, do a quick check in the SCS software to make sure the connection is live. As mentioned earlier, rock devices are monitoring vibration continuously and permanently as soon as they are powered on. It's pretty simple and pretty powerful. And finally, we just wanted to fly through a few quick case studies. There's a published paper from SYSCOM with more details, but I wanted to give you a feel for some real-world applications of rock. In all these, the main features of rock are highlighted. It's cable-free solution, not relying on power externally, something for short monitoring, but some for several months at a time, as well as reporting event data and background reports were important. Here was a demolition monitoring case where they were trying to determine the effect of vibration on the vacant building near a demolished building versus the local standard. Their only requirement for this was PDF for both events and background, which is a very simple handling. And you can kind of see rock at the bottom on the floor there. Piling monitoring, very common as well. Monitor vibration from the vibratory pile drivers near residences. They wanted text alerts for the construction team when their standard was exceeded. So in this, behind the scenes, the SCS software provides the integrated system working that post-processes, reports, and stored all the data from any rock units used in various locations. So where I think this can be a challenge to set up for a lot of systems out there, it's pretty trivial and very easy, and it's kind of a nice revelation when you're using a product like this compared to what you may have been used to in the past. And finally, construction site monitoring. Here, there were two sensitive sites, basically. There was one that was there was a high voltage cable system nearby, and another sensitive site was a sleep clinic. So they wanted to monitor this railway overpass construction for those two sites and compare with the local standard again. They wanted pretty much everything, the background, reports for events, and alerts for the events as well. And you can kind of see on the bottom two photos, there's a rock installed down in the cable doghouse, for a better lack of a word, and in the corner on in the sleep clinic. So all shareholders, you can kind of see how you can have a variety of shareholders, but still keep everyone in the loop that needs to be in the loop. You could alert for one project the shareholders for rock in the sleep clinic to that team, or others that are concerned about the cable system for any vibration that's occurring due to this construction activity to that team. And then you, of course, as the vibration tester, would get all the data as well. So you can kind of see the setups for those three examples were fairly similar. There were only just small changes to synchronization and reporting, but you kind of get a feel for some of the options that you'd have for various projects. The data for the device installed in the sleep clinic is shown here. Maybe a little bit hard to tell in the presentation, but the background recording shows low values over a few days with a different amplitude between the day and the night periods as expected. And then really an event recorded during the period of intense construction is compared with the DIN standard here. The curve relative to the residential buildings, the black curve, isn't exceeded, therefore construction continues. And what happens is, as some of those curves and different standards can have various ramp up points and various points, if that curve is exceeded at any point, even if it's not the majority that's reported on this graph, it will still trigger an exceedance and you'll get full data. You can actually see like full FFT data from any exceedance event as well. And so as we mentioned, rock is only a rental solution worldwide. The model shop rents it for testing in the US. But that said, we do offer other rental solutions, including undetected sound meters, full structural vibration testing, and more. We have a latest rental selection guide for more information on that. And that's about it for today.